30 years ago, the refrigeration engineers at HCR set out to find a better solution than heavy, slow-moving cold storage doors or even fast-acting electrically heated utility doors for moving traffic through cooler and freezer doorways. Using a completely fresh engineering approach and the principles of psychrometrics, the founders of HCR developed new technologies that pioneered the recirculatory air door industry. Today, with more than 30 years of field experience, HCR has gone from the drawing board to the field, from theory to application, from a basic idea to reality, and has proven itself with thousands of successful installations worldwide and inside the largest, most demanding, and cost-conscious retailers and mass merchandisers. With a recent addition of sophisticated computer modeling software, HCR continues to improve its technology for all types of cold storage applications, combining the science of psychrometrics with the art of airflow and metal fabrication. Every HCR product is backed by an unconditional guarantee of customer satisfaction. According to ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, within seconds after a door is opened, a natural air exchange occurs. In a typical two-way air exchange from a cooler to a freezer or a cooler to a non-refrigerated anteroom, dry cold air from the cold side forces through the doorway at the bottom, while warmer moist air from the warm side pours through the doorway at the top. The escaping cold air flows along the floor where it forms fog and chills the floor below dew point, causing condensation to develop, meaning a slippery, wet, or icy floor. Inside the colder room, the invading warmer moist air rises toward the ceiling, where it travels to the coldest part of the room, the freezer evaporators. Along the way, this warm moist air precipitates out and builds as frost. Typical accumulation of frost above the door falls to the floor, turning to ice. The frost also accumulates on the ceiling, walls, I-beams, racks, and even on the product being stored. Psychrometrics is the study of moisture in the air and the changes in air conditions such as temperature, absolute and relative humidity, and moisture content. And nowhere are the effects of psychrometric principles more evident than in a cold storage environment. Traditional cold storage methods of stopping the natural air exchange between rooms with different temperatures have mainly been use of fast-acting vertical or horizontal sliding, bifolding, or roll-up hard doors. Rigid doors are tremendously effective when closed, but their effectiveness diminishes as open and close cycles increase. Rigid doors work well where traffic is low and open and close cycles are few and of short duration, or when the room temperature differences are not extreme. But there comes a point where a rigid door no longer serves as the most cost-effective solution. The more the door is opened, the more air exchange takes place, and the doorway is subject to all of the problems that would occur as if there were no door at all. Cold air escapes, warm air and moisture infiltrate, causing icy conditions on the floor. Frost accumulates on the freezer evaporators and all equipment and products inside the freezer. HCR air doors keep separation between the two rooms, yet allow totally open access. In this way, the open doorway is always closed to prevent costly air exchange, yet always open for absolute accessibility. HCR's model AC air curtain creates a virtual curtain of air that repels the naturally occurring air infiltration. This model is used mainly in high-traffic, non-frosting conditions. When temperature or humidity differences increase, the model CAC, or conditioned air curtain, can be used, which adds heat when needed to condition the air. With model DCAV, or double conditioned air vestibule, the door induces airflow patterns like the single air curtain. When two are placed together and designed to work in harmony, it creates an air vestibule between the two airstreams, where the air is captured and treated to a non-frost, non-fog state. This model creates a vestibule with no visible doors. The 3CAV, or triple conditioned air vestibule, creates an additional vestibule to condition the air. It is used mainly between rooms with extreme temperature differences and very high traffic. The frost elimination process is similar to the model DCAV, but an additional air curtain is added, to improve efficiency as well as increase the model's temperature range applicability. Strip curtains can be added to all HCR models for even greater efficiency in the conditioning process. The model ECAV, which consists of 2 strip doors, also creates a vestibule for conditioning air and is designed for high-traffic freezer and high-humidity situations. Some HCR units can optionally utilize a waste heat reclaim system, making use of the plant's refrigeration waste heat, a byproduct of cooling. When using waste heat reclaim, annual operating costs are significantly reduced. The amount of heat that is required depends on the doorway size, model selected, the type of refrigerant, and the levels of temperature and humidity existing on each side of the opening. Using computational fluid dynamics software, or CFD, shown here is a typical airflow pattern of cold air escaping from a freezer unit onto a refrigerated dock. Treating that same opening with HCR's recirculatory air curtain shows how the air is mixed and held within the vestibule area, minimizing air escape and infiltration. The CFD software also shows us how the air inside the vestibule is captured and recirculated as it is treated to a non-frost, non-fog state. When a forklift or material handling equipment moves through an HCR unit, the air curtain experiences minimal disruption. The air curtain is re-established immediately after a pass-through. The benefits of HCR air doors are visibly dramatic through the elimination of frost and ice, and additionally remarkable in increasing productivity. When applied to large freezers with high traffic or problematic open doorways, fully operational HCR units are essentially the same as adding refrigeration capacity. Merchandise movement is significantly increased, and HCR units help extend critical space utilization. Safety concerns are reduced due to the open space and elimination of moving door parts. HCR makes the appeal of an unencumbered, wide-open doorway for your workers to move about freely and efficiently a reality, removing all obstacles from your path.